A giant asteroid fell to Earth and destroyed all dinosaurs with a blast wave. That's what we've all heard. It was a terrible disaster, but it was actually much worse. You can't even imagine how unfortunate it was for dinosaurs and what kind of disaster they faced. It wasn't just a piece of solid rock from space, but a lump of molten clay. It provoked not just a tsunami, but giant mud waves. It filled the atmosphere, not only with a burnt smell, but also with an acidic and foul smell of rotten eggs. It didn't just sweep everything away with a blast wave. It provoked a volcanic winter, poisoned the air, and blocked the sun. And do you know what the most unfortunate thing was? If the angle of the fall had been just a little bit different, or if it had fallen a little further away, then there might not have been any global catastrophe. That asteroid, the size of Mount Everest, fell in the coastal part of the Yucatan Peninsula. This place separates the Gulf of Mexico from the Caribbean Sea. The asteroid touched both solid rock and water and immediately triggered strong tsunamis and mega ripples. These are large sand waves that are normally about 3 feet long on average and leave a pattern similar to dunes on the seabed. Oh, by the way, they're really called subaqueous dunes. So, when the meteorite fell, it formed 52-foot-high mega ripples. Can you imagine? Giant waves of sea mud that are almost as high as a 5-story building. But how did the scientists figure it out? They used 3D seismic data and modeled the mega ripples pattern in the program. The data was based on the landscape of the bottom, which was impacted 66 million years ago. First, a powerful strike triggered a strong earthquake that liquefied the seabed layer, and then a high-grade tsunami triggered those mega ripples. That is, while giant waves on the surface flooded the land and went into open waters, large mud waves destroyed the seabed. Ancient fish, dinosaurs, and other underwater creatures didn't stand a chance. But what does this information tell us? Well, first, studying the effects of ancient tsunamis helps to reconstruct the past of our planet. Secondly, it helps us to be prepared if something like this happens in the future. Predicting a scenario like this could save countless lives in case of danger. Okay, there was a total mess in the water at the time of impact. But what was happening on land was much worse and scarier. But let's discuss the meteorite itself first and what it consisted of. The scientists analyzed the rocks at the impact site and saw traces of carbonaceous chondrites. This is the rock that makes up most of the meteorites in space. Often this rock contains water, clay, and organic compounds with carbon. It means that, in a sense, a lump of dirt the size of the highest mountain on the planet fell on Earth. And yes, carbonaceous chondrites often have an unusual smell of rotten eggs, tar, or wet hay. So it wasn't just very loud, but it also probably smelled bad. It was a fetid rocket on a planetary scale. However, at the time of the fall, not a single living creature was there to sniff it. All of them lost their lives in the first seconds of the disaster, hit by the devastating blast wave. It set a chain of events that later wiped out all the dinosaurs from the face of the Earth. The peninsula where the meteorite fell turned into a large crater in an instant. Thousands of tons of soot and ash were released into the air. A huge area was filled with thick smoke. The sky turned gray. Black clouds obscured the sun. But wait, where did the ashes come from? The crash site contained huge reserves of flammable materials. In simple words, the meteorite fell into a giant barrel of fuel which started to burn. The sky remained dark. Grass, plants, trees, and bacteria couldn't get enough sunlight. The green world began to wither. And this affected not only the impact site, but almost the entire continent. Even dinosaurs, living far away, felt the low temperatures and lack of ultraviolet light. Dinosaurs couldn't survive in such conditions. The environment was changing too fast. Then it got even worse. A firestorm was spreading in all directions from the place where the meteorite had fallen. The air inside the storm was poisonous and dangerous to inhale. And you know why? Because the meteorite fell in a coastal area and destroyed the seabed. And under that seabed, there were large reserves of sulfur. This toxic mass rose into the air, mixed with ash, soot, red-hot pieces of rock, and meteorite particles. Then the winds picked up this cloud and began to spread it across the continent. The rainforests that survived the blast waves were still in danger, as the hot toxic cloud rained down red-hot ash upon them. This caused large-scale fires. The smoke from the burning trees rose and became part of the destructive cloud. The more trees burned, the larger and thicker the poisonous ash cloud grew. What could have stopped this catastrophe? Rain clouds filled with water, right? Good point, but they didn't. When the hot ash and sulfur fumes mixed with water, they created acid rain, a downpour of poisonous, corrosive mud that wiped out all life around it. Fires, firestorm, acid rain, sun blockage – how could dinosaurs survive after that? Where could they escape? Perhaps the ocean shore? Bad idea. Yeah, the water could have protected them from the fire and ashes, but there was another problem. Do you remember mega ripples and giant tsunamis? A huge wave that hit the shore at that moment could easily wash away New York. Smaller waves rolled across the Atlantic Ocean and the North Pacific. So, if dinosaurs on land had tried to hide near the shore, they would have been swept away like specks of dust by that giant tsunami. But what about underwater dinosaurs? They were not affected by the tsunami and the fire cloud, but they were trapped. Red-hot poison particles of ash and mud fell into the ocean in huge quantities and poisoned the water. Algae and phytoplankton were destroyed. Because of this, millions of fish lost their food supply. And as a result, larger fish and marine dinosaurs were left with nothing to eat. Large-scale famine triggered extinction in the ocean. Toxic particles poisoned the water for many marine life forms. The gills of fish couldn't extract pure oxygen from the water, which only worsened the situation. Near the Yucatan Peninsula, the ocean floor with its coral reefs and ancient sea creatures was destroyed. This huge part of Earth's biodiversity disappeared, upsetting the balance of the oceans. Of course, the destruction couldn't go on forever. At one point, the ashes cooled and settled to the ground. The sulfur cloud dispersed, the fires went out, and the air became clearer. Warm rays of sunlight began to shine down on Earth again. But there was something sinister about the silence. The planet no longer heard the rustle of pterodactyl wings, the roar of a hungry Tyrannosaurus, and the noise of a velociraptor's fast feet. The storm had passed, along with the dinosaurs. By the way, some flying lizards and small animals survived. Later, they evolved into modern mammals and birds. It wasn't the meteorite that destroyed dinosaurs. Fires couldn't do it either. Dinosaurs disappeared because of the famine caused by the catastrophe. Disruption of the food chain led to the mass extinction of these magnificent lizards. After the catastrophe, life began to blossom again. However, the emergence of large mammals was still a long way off. But now, millions of years have passed. Large elephants, rhinos, and other animals walk on Earth, along with the most unique mammal on the planet, the human.
Billions of years ago, our whole solar system was nothing but a big cloud of dust and gas floating in space. Then, something happened to disturb that cloud, but scientists still aren't sure what exactly it was. It could have been a distant star that turned into a supernova with a bang that caused the dust cloud to start spinning. As it spun faster, the dust and gas got pulled into the center and created a thick, spinning disk called a solar nebula. The gravity at the center became so strong that hydrogen atoms started crashing into each other, producing helium and a lot of energy. As a result of all these space shenanigans, we got our sun about 4.6 billion years ago. This process used up more than 99% of the dust and gas in the big cloud. The leftover stuff started to come together to make different shapes. The cloud kept spinning, and bits of matter bumped into each other and stuck together. Some of these clumps got big enough to have their own gravity, which pulled even more matter to them. This is how the planets, including our Earth, were made. You wouldn't recognize our planet though. as it was nothing like we know and love it today. It was hot, and I'm not talking about perfect beach weather hot. It was scorching hot, as it was mostly made of magma, which is basically melted rock. Just imagine how hot it should be to make the stones melt. After a few 100 million years, Earth started to cool down. As the planet changed and its outer crust started to form, there were lots of volcanic eruptions. These volcanoes released water vapor, ammonia, and carbon dioxide into the air around the planet. Slowly, oceans started to form from the water vapor. The planet was every introvert's dream back then, with not a single living being around until the day when the first simple lifeforms began to appear and live in the new oceans. Those tiny organisms were single-celled microbes that gave birth to all future lives, including yours. They left signs in rocks that are about 3.7 billion years old. The signs were a type of carbon molecule made by living things. Then, at least 2.4 billion years ago, cyanobacteria evolved. These were the first organisms to make food using water and the sun's energy, and they released oxygen. This caused a big increase in oxygen, which made it hard for other microbes that couldn't handle oxygen to survive. Then, tiny microbes started living inside other tiny microbes. This way, they were forming organelles, small structures inside a cell with a specific function. One important organelle is called mitochondria, and it helps turn food into energy. For the first time, DNA got packed inside a part of the cell called the nucleus. These new complex cells, called eukaryotic cells, had different parts that each did a special job to help the whole cell work better. Soon enough, the earliest animals would rule the world. But don't get your hopes up. They weren't fluffy kittens. All the changes on Earth were happening against the background of the supercontinent Rodinia, which formed around 1.2 billion years ago. It pulled together almost all of Earth's land masses into one gigantic piece of land. It was surrounded by a massive ocean, so the whole planet looked like a giant land and sea puzzle. Unlike the green, lively continents we have now, Rodinia was barren and rocky, with no plants or animals on land. So, early life forms like algae thrived in the ocean. The breakup of Rodinia caused changes in Earth's climate and ocean currents. New coastlines and environments eventually helped diversify life on Earth. Cells began living together and finally evolved into the first animals around 800 million years ago. Sponges, and I don't mean the loofah you use to shower, were some of the earliest animals. By around 580 million years ago, they had neighbors, including fronds, ribbons, and quilts. But then, another 40 million years later, which is like a minute in evolutionary time, the conditions changed. Oxygen levels rose, and the first animals were replaced by new life forms. It was the beginning of the Cambrian period, the time of the giant shrimps and other creatures you'd rather never meet. Those invertebrates that ruled the planet looked so weird and not Earth-like that it took scientists years to realize these scary creatures were actually the ancestors of modern mollusks and crustaceans. Meet Hallucigenia, a creature with 7 or 8 pairs of spindly legs, the same number of paired spikes coming from its back, and a head you won't tell from its tail. Another cool creature from that period was the abnormal shrimp. Unlike most animals back then that were tiny, it was over 3 feet from head to tail. There was also the Weewaxia, that looked sort of like a stegosaurus, but without a head, a tail, or any legs. It looks like these creatures were born without defensive spikes and grew them as they got older. If they ran a beauty contest in the Cambrian period, Aishia would likely win. It had many common features with today's tardigrades. Although it was just 1 or 2 inches long, it was the nightmare of prehistoric sponges, and it clung to them with its multiple claws. We still have some live souvenirs from the Ordovician period living among us. Take lampreys, for example. The marine life kept flourishing. There were squid-like nautiloids with tentacles and a special shell with gas-filled chambers that made them float in the water. They swam well by squirting water out of their bodies and used their tentacles to catch prey. Another group of sea hunters was the conodonts with their tiny fossil teeth. The few complete fossils we have found show that they looked like eels with big eyes to spot their food. Fish back then were small, with mouths that pointed downward, which helped them suck up food from the ocean floor. Lampreys and hagfish are their living relatives today. The hard-bodied arthropods, like early relatives of crabs and spiders, started exploring life on land. They moved into freshwater and shallow lagoons, and one type of these creatures was the horseshoe crab. Even though they're called crabs, they're actually more like spiders and scorpions. Around this time, the first simple plants also began to grow on land, but a surprise ice age interrupted their plans. Most of the world's land at that time came together to make a huge supercontinent called Gondwana. It included what is now Africa, South America, Antarctica, and Australia. Another supercontinent, called Laurentia, included what would become North America. Gondwana drifted south until it settled at the North Pole. Huge glaciers started forming over what is now Africa. This led to a 20-million-year ice age and a huge extinction. At least half of all marine species were wiped out around 443 million years ago. The landscape wasn't looking too cozy, but have no worries, the first plants were about to hit the land. As temperatures rose and sea levels climbed again, the oceans began to recover during the Silurian period. Huge reef systems grew in the warm, clear tropical seas. You can still see remnants of these ancient reefs today. They are limestone rocks. The oceans were full of tiny creatures called plankton. At the top of the food chain were these terrifying sea scorpions. Some of these sea scorpions grew to over 6 feet long, and they were the largest arthropods ever. They looked like giant scorpions with huge, compound eyes to spot their prey, the primitive fish. They caught it with their strong, claw-like pinchers. Speaking of fish, they were starting to change and found new ways to eat, not just by sucking up food from the ocean floor. A group of spiny sharks developed jaws which made their mouths more dangerous. Even though these jawed fish weren't very big during this time, they were becoming better hunters and would later become top predators. On land, the first tiny, creepy crawlies began to show up. They were primitive centipedes and early ancestors of spiders. The first plants on land didn't have leaves, but they could stand up straight, thanks to their stiff stems. They also had special tubes inside them to move water and nutrients around, just like how our veins move blood. Mosses and other small plants soon followed and helped create a better environment for animals to start living on land too. The climate was nice and warm. The supercontinent Gondwana was still near the South Pole, but the big ice sheets from before melted away. Plants continued to grow and change during the Devonian period, but you'd probably be more impressed by a millipede as long as a car. If you visited the Earth back then, you'd wander in the first big forests made up of lycophytes, horsetails, and ferns. By the end of this period, the first successful trees appeared. They could grow really tall, up to 98 feet, about half as tall as the Leaning Tower of Pisa, and had thick trunks about 3 feet wide. They didn't have real leaves but had fern-like parts growing right on their branches and used spores to reproduce. The insects of that time were pretty wild. One of them was a huge dragonfly with wings as wide as a big pizza. This giant dragonfly lived in open places where it had room to fly, and its big eyes helped it spot its food, smaller bugs. It used its spiky legs to grab the insects it wanted to eat. Another monster from that time had wings about 22 inches wide and a mouth that looked like a beak. On the ground, the biggest bug ever known on Earth was wandering wild and free. It was a millipede as long as a car that likely ate fruits and seeds. The insect grew into such giants thanks to the extra oxygen in the air, up to 35% instead of the usual 21%. They could easily breathe even when they were huge, and there were no big birds to eat them, so they could grow really big and explore land and sky with nothing to worry about. But not for long. Fish started changing into the first animals that could live on land. These early fish had special fins that worked like arms and legs, and they could explore new swampy areas where there were lots of plants and no big predators. One of the oldest animals that show this change mostly lived in shallow water, where it walked on the bottom. It had a head that looked like a crocodile's, and it could move its neck and breathe air through its nostrils. It grew up to 10 feet long. Its back fins were bigger and stronger than the front ones, which helped it move on land. At the end of the Devonian period, Earth went through 2 long extinction periods when up to 70% of sea creatures disappeared. But the plants and animals living on land mostly survived these tough, cold times. It also had a cool, distant cousin, coelacanth. This fish was almost 5 feet long and had 4 fins that looked like limbs, but it never moved to land. It adapted to life in deep water, hiding in caves during the day and hunting at night. This deep-sea lifestyle probably helped coelacanth survive 4 of Earth's major mass extinctions. For a long time, people thought it was extinct until one was found off the coast of South Africa in 1938. So yep, it still lives in the deep parts of the Indian Ocean. During the late Paleozoic era, animals including a crazy mix of a polar bear and a saber-toothed cat got all independent and didn't have to live near the water anymore. They started laying eggs on land. Fish were becoming more different from each other, and trilobites were starting to disappear. New plants called conifers were growing, and 2 new types of animals also appeared. There were marine reptiles like early lizards and snakes and archosaurs, which later turned into crocodiles, dinosaurs, and birds. This period is sometimes called the Age of the Cockroaches, because an early kind of cockroach was lurking all over the world. But there was something way cooler than a cockroach, like a mix of a polar bear and a saber-toothed cat. It was an early relative of today's mammals with long legs that helped it run fast. It had sharp, saber-like teeth that could slice through the necks of huge plant-eating animals, but it used its teeth to rip big chunks of meat rather than chew. Scientists aren't sure if it had scales like its older relatives or fur like its mammal cousins, but they found hints of ancient poop that smaller relatives had hair, so this guy probably did too. There was also a big reptile that lived in the cold deserts of Eurasia. Imagine a creature as big and heavy as a black rhino, weighing about 2,400 pounds and stretching around 10 feet from head to tail. It was covered in thick, bumpy plates all over its body, which helped protect it from predators. Because it was so heavy and slow, it couldn't run fast, so these tough plates were its best defense. To stay so big and strong, Scutosaurus had to eat a lot of food all the time. It was one of the first big plant-eating animals to live on Earth. These animals were like early versions of big dinosaurs that came later. Even though Scutosaurus looked a lot like those dinosaurs, it was not closely related to them, kind of like how we're not closely related to whales and dolphins. The closest living relative to Scutosaurus is the tortoise, another slow-moving armored reptile. When you look at this guy, Dimetrodon, the first thing you notice is the big sail on its back that could remind you of some dinosaurs, but it was actually more closely related to us. It was a proto-mammal and had some unique features, especially in its skull. It had a small hole behind its eyes where jaw muscles attached, which is something dinosaurs didn't have. Dimetrodon also had different types of teeth for different uses, unlike dinosaurs that had rows of the same kind of teeth. The sail on its back was probably used to show off and attract mates, or scare away rivals. The last period of the Paleozoic, called the Permian, ended with the largest mass extinction on Earth ever. It wiped out more than 90% of all the species on the planet. The two big landmasses named Euramerica and Gondwana joined together to form one huge supercontinent called Pangaea. Around Pangaea was a giant ocean. Because Pangaea was so big, the middle of it was probably very dry, since rain clouds couldn't travel far enough to bring water to the interior. This made Pangaea's center a very dry place. The Permian extinction left room for new creatures to thrive. One of them was this guy, looking like a real-life Nessie from Scotland. It was a 20-foot-long reptile with a super long neck, even longer than its body and tail combined. And nope, it wasn't a dino yet, but a protosaurus that lived during the Middle Triassic period, which was just before the time of the first dinosaurs. Scientists used to think it was too heavy on top to walk on land because of its long neck, but newer studies show that most of its weight was centered around its body, so it could walk just fine. Between 240 million and 230 million years ago, a new successful group of animals started to rule the world. They managed to evolve from mostly dog and horse-sized creatures into the biggest monsters that ever existed on Earth. Scientists say they managed to do it thanks to some massive volcanic events. But it's a topic for another video. Life during and after the dinosaurs.
The Tyrannosaurus rex, the formidable predator, the world-known celebrity of the animal kingdom, the king of all dinos. Since its discovery in 1902, this dangerous predator has fascinated both researchers and the regular public. But despite its terrifying reputation, there were actually other beasts that could defeat the T-Rex. And one of the true nemeses of this dinosaur was the Triceratops, a herbivore. But despite its plant-based diet, the dino was huge and had two nightmarish large horns and a smaller one, along with thickened bones which added to its defenses and helped protect itself from dreadful predators like the T-Rex. This dino was something like proof that herbivores were no pushovers. Its formidable horns were about a foot wide at their base and tapered into mean points capable of skewering any predator, even a T-Rex like Juicy Barbecue. The colossal skull of the Triceratops sported an enormous frill made of protective solid bone, which was topped with hornlets. From the tip of the animal's beak to the spiked rim of the frill, the head of the Triceratops could reach a whopping 10 feet in length and weigh around a ton. This gargantuan construction, the head of the dino, was attached to the body with the help of a ball and socket joint. This allowed the dino to swivel its head around with astonishing speed, brandishing its horns to scare predators away. That's one of the reasons why a T-Rex that decided to attack a Triceratops was actually taking a big risk. The battle could easily go either way. Of course, the king of the dinosaur world could win and get its long-awaited feast, but just as likely, the hunted could become the hunter and end the T-Rex's game. Now, how about we find some more cool and lesser-known facts about those intriguing creatures, dinosaurs? For example, dinos almost certainly did not roar. Scientists think they might have cooed instead. More accurately, they probably produced sounds in ways similar to the way ostriches boom or doves coo. You see, many modern birds use a method of producing sounds called closed-mouth vocalization. Sounds are made by inflating the throat rather than passing air through the syrinx, the vocal organ of birds. In other words, the Jurassic Park movies got it all wrong. A lot of early dino reconstructions appeared under the influence of those scary noises that we associate with modern predators, like lions. So, on screen, dinosaurs have their mouths open when they produce sounds, just like lions when they roar. But real dinos wouldn't have done that, especially not before charging at their prey. They wouldn't have advertised their presence to other animals nearby, not when all they wanted was to have a meal. The Quetzalcoatlus was a member of the ancient group of flying reptiles, pterosaurs, and it was also the largest flying animal to have ever lived on Earth. The giraffe-sized creature had thin limbs, a startlingly long beak, and a staggering 40-foot wingspan. Researchers believe that these creatures could have also used their folded-up wings as legs, so they probably walked on all fours. Scientists discovered the Quetzalcoatlus about 50 years ago, but they still have a tricky time trying to piece together the details of this animal's life. For example, how did it even manage to lift its ginormous body off the ground when flying? Whatever the answer is, this creature is our first real look at the entirety of the largest animals ever to fly. One of the reasons why it's been taking so long to unearth the secrets of the Quetzalcoatlus is because this creature had hollow bones that helped it to fly, just like modern flying animals. So, when you find these potato chips-like bones preserved in super hard rock, you need to somehow remove them without destroying them, and that's a really tough task. The Tyrannosaurus rex was quite a slow runner. Its speed was likely to be just about 10 miles per hour, which is approximately as fast as the speed of an average human runner. As for T-Rex babies, according to hatchling recreations from the American Museum of Natural History, they were pretty cute. About the size of super skinny turkeys and covered with downy feathers. The largest land-based dino was the Argentinosaurus. This massive animal often reached up to 130 feet in length and 69 feet in height. Considering the average blue whale is around 70 feet long, you can easily imagine just how giant that dinosaur was. Many dinos had feathers, and I'm not only talking about avian ones. The largest feathered dinosaur we know about was the Eutyrannus huali, which translates as a beautiful feathered tyrant. It was a super predator and cousin of the T-Rex. Scientists think that the dino most likely relied on its feathers to stay warm. However surprising it may sound, some of the biggest dinosaurs were actually herbivores. Let's take the Brachiosaurus and Apatosaurus, for example. These creatures were giant, but followed a plant-based diet. Now, I'm not sure if you should try it or not, but apparently, you can tell the difference between a simple stone and a dinosaur fossil by licking it. It may not sound like the most legitimate approach, but even paleontologists sometimes find themselves doing this. The thing is, if you lick a potential fossil, it will slightly stick to your tongue. That's because fossils are way more porous than stones. When dinosaurs first saw the light of day during the Triassic period, around 230 million years ago, Earth's continents were clustered together and formed one giant supercontinent called Pangaea. Over the next 165 million years, Pangaea slowly drifted apart, and that separated many dinosaur species from one another. And still, most of the world's dinosaur fossils are found in three places: the high-altitude Badlands of China, North America and Argentina have the largest amount of fossils, or at least easily accessible ones. In reality, most parts of the world are covered with fossils, but those located in desert-like environments are easier to find due to the lack of vegetation. Interestingly, most fossilized dino bones aren't bones anymore. The fossilization process often occurs when something gets trapped between layers of sediment or sand. For millions of years, those remnants stay there. At one point, they got surrounded by a layer of water. It replaces the original organic material with minerals. In other words, it's not the real thing anymore. It's a rock-like copy. The Triceratops boasted 3 giant horns sticking out of its head, but its teeth were even more fascinating. This dino had around 800 teeth, and new ones kept growing throughout its life. These teeth grew in sets of 36 to 40 tooth columns, with each column having 3 to 5 teeth, vertically stacked on one another. Some dinos had hollow bones, like today's birds. These creatures stored air in their bones, which helped them improve their breathing abilities. It made these dinosaurs lighter on their feet and allowed them to breathe much more efficiently. The Nigersaurus replaced its teeth every 2 weeks. This unique creature had rows and rows of teeth in reserve. They were hidden away in its mouth, and when a set of teeth wore out, they fell out, and the next row moved into position. Dinosaurs didn't all go extinct at the same time as soon as the asteroid crashed into Earth. Instead, the space rock likely triggered a chain reaction of events which changed the face of the planet. Of course, it didn't happen overnight, but over the next few hundred or even thousands of years. As a result, all but avian dinosaurs went extinct. The word dinosaur came from the Greek language. Deinos means terrible, and sauros means lizard. So basically, dinosaur can be translated to terrible lizard. You may object that not all dinosaurs were terrifying predators. This name might be appropriate for the T-Rex, but not, let's say, the tiny May. Rumor has it that when Sir Richard Owen, an English biologist, came up with the name for dinosaurs, he used the word terrible in a different sense. He described those ancient creatures as fearfully great, as in far larger in size than any previously discovered reptiles.